general relativity, step by step. I've got demand here for the divergence of this term here to be equal to 0 because I'm using it as a candidate for the left-hand side of the field equations. So what I'm going to do is to investigate what these constants that are, b here and this lambda here, and I'll see what we can make of that. Well, let's have a look at this one first because it's easiest. Let's have a look at this alpha beta. Well, I'm just going to make the observation that that equals that times g alpha beta semicolon beta, because it's a constant. This is a constant. Equals lambda times 0 equals 0, of course. Why is that? That's because the covariant derivative of the metric tensor is identically equal to 0. Why is that? Well, here's me in interstellar space. There's a black hole here and another black hole here, or maybe orbiting around each other. Who knows what they're doing? And so what I do is I build an elevator around myself and construct coordinates, local inertial coordinates, because if I close my eyes and don't look out of the window, as far as I'm concerned, I'm in flat space. So there's my metric tensor. I think you normally call it, oops, that's not the symbol I meant that. You normally call it that. And of course, the ordinary derivative of that is equal to 0. And so what that tells me is that my metric tensor alpha beta, comma beta equals 0, from which I can deduce, and that's a valid tensor equation, so I can use the comma goes to semicolon rule and deduce that alpha beta semicolon beta equals 0 identically. Identically. Very useful line of logic. So what does that tell me about lambda? That tells me, going back to this thing here, that lambda can be anything. Can be any scalar value. At the moment it's unconstrained. Mathematically speaking, lambda is unconstrained. If we want to determine what it is, we need to use observational techniques. We need to observe the universe to try and figure out what this thing here is. But as far as the mathematics is concerned, at this stage at least, we have no restrictions on what lambda is. We don't know anything about it at all, except that it's constant. And you'll see that it's a constant that's unaffected by the matter fields that are present in the space that you're considering. This is a feature of space itself. Yeah, this thing's unconstrained, and we need observational constraints to pin down its actual value. Well, we've done this one here, and I'll do B in the next screencast. It's considerably harder to evaluate B, as you might expect, because it's a more complicated beast, because it's got the curvature scalar in it. But I'm going to stop there, and we'll talk about B in the next screencast. Stop.